topic 3. So one thing that I want to make sure that you know how to do for the quiz is that, remember, topic 3 is on logical operators and logical indexing. And so on the quiz, I'm going to be looking for you to not use intrinsic functions like find, but to instead use it be able to do the same logic with just logical indexing. So here's an example. If you're trying to find the elements of the X array that are less than or equal to 40, you can use the find command, and the find command will give you the indices where that condition is true. And then if you plug those indices back into the original X, it'll show you the values associated with those indices. So we've been doing that a lot in our assignments. But using logical indexing, you can do the same thing. So I have the same X array, but here I am. Sorry, this recording doesn't work if I'm not by the computer. Maybe you've noticed that. Instead of putting find and then the condition, you can just put that relational condition into the command window, and you can give the result of that logical condition a variable y, the same thing. But what will come out of that instead of the index locations is the true and false statements for each element. So here, this is the same result as this. It's just giving ones and zeros. You can plug those ones and zeros back in and get the values just the same. So this is one example of how you could replace it. Every logical or relational condition that you're trying to do will have a different way of converting it, but I just wanted to make sure that you know that that's what we're going to be looking for in the quiz. Any questions about this? Okay, so let's review a little bit about loops, because that's what we're going to be doing today. So I showed you both what a for loop is and what a while loop is, and I gave you this motivating example of a for loop is when you have a predetermined number of times that you're going to run a set of commands. So with this example with Burke, I said run around the loop 3 times. I told him exactly how many times to do the same command. And that's what a for loop is. And the syntax for the for loop is right here. You have the for in the end wrapper, and then the condition next to the for is the array that is telling it how many times to run the loop. Typically we use an array I equals 1 to some number, but that array can actually be any array. It doesn't have to be in increasing order. It doesn't have to be integer values. It doesn't have to be anything. It'll just run the loop for each element of that array. Practically, we almost always use some sort of increasing counter. The while loop, on the other hand, the example for that I gave with Burke was I said run around the hoop until I say stop. So instead of telling him how many times to run around the hoop, I said I gave him a condition, and the condition was until I said stop. So that's how a while loop works. It runs until a condition is met. So the wrapper is while and end. There's a condition here, and then as long as that condition is true, the commands will continue to run. We've also been doing if statements, so we just had a clicker that kind of helped review that as well. And if statements have all of these different options. There's an if, an else if, and an else. You can use any combinations of these. You don't have to have an else if, you don't have to have an else. The only requirement is the if and the end, and then these two are optional. So the way the if statement works is the commands between if and else if will run if condition 1 is true. The commands between else if and else will run if condition 2 is true, but it only gets checked if condition 1 was false. And then the else statement only runs if all of the other else and else if statements above it were false. This one is the most straightforward, and I find that when I ever ask anyone to read through an if statement, they almost always understand what the if statement is saying, even if the syntax is new. It's the loops with the if statements that make it a little bit harder. And the last thing we learned about last time is the memory allocation, which we just talked about a little bit with the clickers. You can define these arrays element by element using loops like this. And this was the activity we did up here where we had people holding boards to kind of show you the difference. If you do it this way, it's going to take up 6 places in memory because it's going to create 3 different arrays. The first one will have 1 element, the second one will have 2 elements, and the third one will have 3 elements. Method 2 pre-allocates the array to have 3 elements. Memory is allocated for those 3 elements, and then each of those elements is filled with its proper value. And this is the proper way to use a loop that is creating a new variable. Alternatively, what we've been doing in previous topics is using vector notation and not using loops at all to define. But all 3 of these things do the same thing. And probably method 3 in this particular case is best, and it goes worse from there. Okay. I also wanted to show you something that might be useful for your quiz. Whoops, not supposed to leave. Which is something that we're going to see more and more as we continue to go through topics. So this was from quiz 2. You had an array that had 2 columns in it, and you were asked to multiply those 2 columns by each other. And this was just a selection of 4 different ways people did this, and I thought this was an interesting thing to show you. So some people went through and actually called out specific elements and multiplied them individually row by row. So they took the first element times the second element and put that into another array that's in the first element spot. And then they did that for each row individually. Some people did the same thing, but they used double index notation. So these are the 2 worst ways to do it, right? But not wrong, just really easy to make a mistake. And the averages they used, they just added up the elements 1 by 1 and then divided by a set number. So if you had a different size array, this wouldn't work anymore, right? A better way is to pull out each column and do the element by element multiplication, and then using the sum and length functions, which are general, so if anything changed about the array, that would also change. And an even easier way is to not even create a variable here, because unless you needed it again, it's just wasting space, and using the mean function. So I kind of wanted to show you this transition of like all of these are correct, but one of them is best. And this is going to become increasingly more important as we start programming, because you might do things like this the first time you program. It's very inefficient. It's very messy. And I prefer you to do it like this if this makes sense to you than to do it like this because someone told you that's the right way to do it. Because you won't learn how to program if you're just trying to go to the most efficient way that someone is telling you to do first. It won't work. The logic won't be developed, okay? So that's going to be particularly true as we start developing bigger algorithms. So today what we're going to do, and I'm going to come back to this, is we're going to start working through some algorithms that are classic programming algorithms that all programming classes usually touch on. So today we're going to do a find and search algorithm, as well as a counter and an algorithm that removes data. In the lab, you're doing a very similar one to the one we're doing. You're also programming a max, and you're doing a guess and check algorithm for B. So I sort of teach this class in more of a applied approach, where we don't talk that we're trying to problems we're trying to solve, and the algorithm just falls out naturally. But I do like to just at least reference the name of the algorithm so that you can see what it is. For today, I'm actually going to do some writing because I want to write out the steps that I want you to write out in your pre-labs. So I'm going to give you examples for both of them. Okay. So I'm going to do 2 examples. The first example 1, is a grade sorter. That's the one that's going to be the searcher or the find algorithm. And this algorithm is the point of the algorithm is it's going to take in numeric scores that perhaps test scores, and it's going to find the equivalent letter grade associated with that score, as well as count the total number of students who got each letter grade. So for now, we're just going to have a designated array holding the scores, and we're going to do it with that designated array. But you could have this be a function that you could input scores and get output grades from, which we'll do maybe later. So what I'm going to do is I'm going to go through these steps that you guys should have been doing for each of your labs so far, which is to read the problem statement, solve it human style. I'm using the same numbers. Convert to computer steps. Develop a pseudocode. And then write out in Matlab syntax. And for us, we are going to do step 4 in Matlab and run the code, and we'll write out steps 1 through 3. So I want, as we're going through this process, think about the one that you're going to be working on in your lab. And the one that you're going to be doing is you need to write a code that's able to find the max of an array. So the first step for this grade sorter, what's the first thing that you would need in order to convert the scores into letter grades? What do we need to start with? What would be? We need the scores, right? So step 1 is we need the scores. And then step 2 that we're going to do is, in addition to the scores, we're going to need to decide on what ranges of scores are equivalent to what grades. So we need the letter grade ranges. So because I don't want this to be super long, I'm going to just use, I'm not going to do pluses or minuses, so I'm just going to do the A through F ranges. So we have A, B, C, D, and F. And so we can think about this. Let me just give you a dummy array of scores so that as we're thinking through this algorithm, we can have an example array to think about. So here is a set of scores stored in an array. So how would you go about determining which ranges these scores were in? Anyone have a suggestion? Just don't think about what the computer algorithm is. What would you do? Someone just said you would look at them, so I'm going to look at the first one, and then what would I do to determine its letter grade? Yeah, you would compare it to these ranges, right? And you would determine which one that it fit into. So let's write that down. So let's check the first value. And determine which range it falls into. And now we just need to talk a little bit about what the goal of this code is. So the goal is to report back for each score the letter grade for that score, as well as the total number of scores that were within each range. So the next 2 steps will just accomplish those 2 tasks. So the first one is to create a new element that holds the letter grade, perhaps of another array that's holding the letter grades. And then the last step is to count the grades. So that was for the first one. So that would do it for the first score. So what would you do for the rest of them? You would repeat steps 3 through 5 for the rest of the grades. And then as a last step, you almost always, when you write a code or an algorithm, you have some ultimate goal of reporting back what the result was of whatever it is that you did. So it's almost always the last step. Right now it's usually a display command. Later it will be plots or probably even outputting data to another file. Okay, so this is, we read the problem and we did the human steps. So now what we're going to do is convert all of these steps into the equivalent way that the computer can do those. So we need the scores. This step is a variable definition. So for this, for step 1, all we need to do is define a variable. For step 2, these are all relational operators. All right, what about step 3? How do you do a check step? What kind of statement would do a check? What's that? Yeah, so that will come from the relational operator. And then what kind of statement will check something? An if statement, yeah. So anytime you're trying to check or compare things, you want to think if statement, especially if you're doing lots of them. And then, okay, and then for step 4, you need to create a new element that holds the letter grade. So this is going to be a variable definition again. Step 5, you need to count the grades. That will be a counter. So a counter is something, we've used this before, it's something where inside a loop you're basically stepping up a counter every time the loop is executed. And then anytime you're writing out steps that says repeat, you want to think loop, and in this case, is it a for loop or a while loop? It's a for loop because how many times do you want to run the loop? 7 times, or the number of elements that are in your array. So you'll always know in advance how many times to run the loop. And then the last step will be a display. So this is what I'm talking about with step 2, converting into computer steps. So this can kind of start getting your mind wrapped around the logic. And then the last step is to write out the pseudocode. So I'm going to just roughly write out the pseudocode before I type it out in Matlab. And I just want to show you this step because it kind of helps you see the difference between the pseudocode and starting to write it in Matlab. So when you're going to write a pseudocode, you're going to take all these steps that you figured out, but you're going to put them in the correct order. They're not in the correct order usually. Computers don't do things the same as the humans in the same order. So, for example, the first thing that you would do for your pseudocode is you would do your variable definition. That's okay to do. And then anytime you know you're going to do a loop, you just want to create a big wrapper for your loop to start ordering out the logic. So the for loop is going to kind of wrap the entire code. And then inside the for loop, the if statement is going to be nested. So for this case, the if statement is going to check, there'll be a different if statement for each of the score ranges. So we could start with the first one. So I'm not going to write this in proper syntax just because that's not probably what you would be doing if you were doing this. So you have your if statements, and you'll have an else if for the next range. So maybe the next range is when the score is greater than 60 and the score is less than or equal to 70. So you would keep doing this, these else if statements, until you satisfied all the conditions. And then you have to think about what needs to happen inside each if statement. So there's two things, steps 4 and 5. You need to save the element that holds the letter grade, and you need to do a counter. So for example, maybe you would have another variable nested inside here that would define the letter grade associated with that condition, and then you would have a counter that would keep track of how many there are in that range. So what would we need to do with these two variables before we start doing stuff inside the loop? You need to either pre-allocate them or initialize them. So with the letter array, you're going to need to pre-allocate it. You're going to make that a cell array, so you're just going to use the syntax appropriate for pre-allocating a cell array. And then for the counter, you just want to initialize the counter to something. So currently there will be no letter grades associated with each score. And for this one, you'll probably need to have 5 of them, but this is just to kind of get you an idea of like the shape of the pseudocode. Does this make sense? How I went from the steps to the pseudocode? Okay, so now let's move over to Matlab. And I'm just going to start writing this out in syntax now. So I'm going to start by defining, I'll just use the same scores that I defined before. So I have my scores, and then according to my pseudocode, I said I need to pre-allocate the two things that I'm trying to create. So the syntax for, I actually forgot, so let me open up. Syntax for this. Okay. So the syntax to pre-allocate a cell array that you can use is cell, and then the size of the cell that you would like to use. So here I'm going to do the length of score, comma 1, and that will create a cell array that's the same size as whatever the array that's holding the original scores. And then for the counter, we're going to have a counter that we're going to have a counter for each group. So how many groups are there? How many ranges are there? There's 5, so I'm going to just create an array called count, and each element of the array will hold a different number for each of the ranges. Okay, so I'm going to build my wrapper for my for loop, and then I'm going to build my if statement as well. So for this one, there's 5 conditions, and what I'm going to do is I'm going to go ahead and create all else if statements. So I'm not going to have any conditions where there isn't a requirement for it to satisfy to go into that condition. So I'm not going to have an else condition. So let's create our array for our for loop. I'm going to do I equals 1 to the length of score. So that will run this loop for every single element of the score array. And then I'm going to create all the conditions. So this is where you're going to have to start getting used to indexing your arrays, because now you're looking at just testing each element independently. So the first condition I'm going to do is when score is less than 60. So If score is less than 60, then I want to fill the element associated with that score with a F. So what I'm doing here is I'm calling out each element. So when I equals 1, it's going to check the first element of score. If that first element is less than 60, it's going to put an F in the first element of letter. So letter will hold the associated letter grade for the same element's score in the score array. And then I need to advance the counter as well. So for now I'm going to use the first counter in the count array to hold the F's. So the first element of this array will hold the number of F's. You don't have to do it that way. You could store them wherever you wanted to. So we basically will need to do that for each of the ranges, but we'll just need to change them. So I'll just put these in each slot, where here will be D, C, B, and A. And then I'm just going to change these accordingly. And then I'm going to go ahead and change the conditions for each of these. So score of I, for this one, is going to be that the score of I is greater than 60, and it's also less than or equal to 70. I wasn't clear about my ranges on which one was equal to and which one was not, so it would have to be specified in the assignment to make that clear, but this is just more for an example. And then for the rest of these, I'm just going to change these to be the correct ranges for each of those grade scores. So from here, do you guys have any questions about the if-else statement or the for loop or the pre-allocating of these arrays? This one? Oh, it might not, no, it will be necessary. So anytime you use these functions that define pre-allocated arrays, like the cell or so the cell array is going to create a cell array, and it's going to make it the size of what's inside the in the input. So it's going to be 7 by 1. Yeah, you have to say the size. It's the same with zeros. To create a zeros array, you have to put the size of the array you would like to use.
In this, if you get the first if statement is true, it doesn't run the rest of them. So wouldn't you not have to do the greater than or less than?
Yeah, maybe. Yeah, that's probably true. Oh, even this statement.
Yeah.
Yeah, probably. That's true. You don't have to.
And when are you supposed to use the double? The double and sign?
Yeah, so we're going to always use the single one. Use the double one if you're comparing arrays, which we're hardly ever doing in the. You don't need to do it ever to do any of the assignments. If you're comparing arrays, then the double is used to compare all elements of the array to each other. So 2 arrays compared to each other. I never really went back to show you that any better than when I first presented it, but you don't basically need to use that method.
Do we have to add that 5 plus 1 line?
Yeah, so this line here is going to take care of step 4, which is to associate those scores with letter grades, and this line is going to count how many of them there were. You wouldn't need to use a counter. You could also, no, you would need to use a counter. So there's other ways to do it though. You could create like a different array for each of these categories, and then the length of that array could also count it for you. Again, I'm just showing you one way to do this, but we should run it and see if this even works. So let's just end this code by printing which letter grades and scores. You should not write your code like I just did, where I just wrote the entire code without ever running it, but it's a really bad habit that I have. So I think all of these have to be in cell things like this. I think you can also do it this way. Let me just double check my notes. Yeah. So we've used this quite a few times with the display command. It's also true for definitions, that if you want to put strings in cell arrays, this is one way to do it. There's also functions that can convert the strings. You guys have all seen this, right? Using the curly brackets. You have a question?
Do you need to make one of the scores involve 16 equals to as well? So that includes 60?
Say it again?
Do you need to, because you have a less than 16 and greater than 60, but no.
Yeah, I really wasn't very careful with that. I might need to have an equal sign here and not here. Like this, you mean? Yeah, it's just score. Okay, so my scores were 60, 75. Yeah, so because I said less than 60 is an F, when it was at 60, it got a D. And then 75 is a C. These are B's, A. So it definitely worked. You could play around with the equal signs to make sure that it's a little bit more consistent with whatever the rule is. I wasn't very careful with it. But this is the basic structure you're going to do for the first part of A, which is you need to find, using a for loop and an if statement, when some conditions are true for your data.
How do you display your counter, or how many times?
Yeah, let's display that too to see what it was. So I can also type out the variable and unsuppress, and it will print how many it counted for each of them. So it counted 0 Fs, 1 D, 1 C, 2 Bs, and 3 As. And again, I just kept track of which of those counters associated with which grades. You could have reversed this, it doesn't matter, as long as you know as you're programming what they're each storing. Okay, so what I'm going to do is I'm going to go through this other example and just present it to you, and then I'll just have to post a video of me explaining this in a little bit more detail, but it's a good practice for your while loops. Now, I just have to give you like a little bit of a disclaimer that some people complain that the types of algorithms that we write are really boring, but like you have to start somewhere. Like you can't just start solving like amazing engineering problems that have these complicated algorithms. So you really have to do examples that are simple enough that you could do the algorithm to start with, okay? So for example, the one that you're going to work on for lab 4A is writing a max function. That's a really good practice on practicing algorithmic. But this one is what I'm talking about. It's so hard for me to come up with ways to practice a while loop where you're required to use a while loop. So this is what I have for you to think about. So imagine that you collected data from an experiment, and the data was recording some strings associated, some character strings associated with the experiment. But the instrumentation had a problem, and every once in a while, instead of printing one H, it printed two H's. And so you want to go through the data and correct that mistake that was done. So all those double H's are supposed to be H's, basically. And you can be fairly certain that there aren't words in the English language that actually have double H's. So the idea is to write an algorithm that kind of goes through and filters out all those double H's. And this is an example where you would need to use a while loop to do that. And so what you're going to do is imagine that you have something like this, an array. And I'm not going to use a cell array for this because it just makes the algorithm a little bit easier to think about. So imagine you have something like this. There were just these words that were printed, and sometimes the words had two H's and sometimes they didn't. So here's just a couple examples. Now, do keep in mind that when you're not using accelerate, all of these are going to get strung together. And what will basically happen, I can show you a little example here on the screen. If I type in 2 words, I'll just type in 2 of them, into an array, and it just is holding character strings, it's just going to mesh all those letters together, and that's why we don't use these. So what I want the algorithm to do is locate the double H's and remove one of them. And how you remove an element of an array is, so which one is it? 1, 2, 3, the 4th or the 5th needs to be removed, right? So if you just type in text and then put in whichever element that you want to remove, and then you put in an empty array, it just takes that element out. This is some feature that Matlab has that most programming languages do not have. It's really convenient for kind of thinking about these things. So the problem is this data that you're dealing with, you're trying to remove all the H's, so you need to find them all, but it's going to keep getting smaller. So this started out one size, and then I took one out, and now it's smaller. So you can't create a for loop, because the for loop will get messed up because the size keeps decreasing. So this is a condition where you would need to use a while loop. So what I'm going to do is I'm going to write this out for you guys and explain it on a video and post it so you can have this example as well to look at to help you get started on the while loop that you're working for your lab. Do you guys have any questions about any of this? All right.
Yeah, it's fine.